Welcome to Impact Info Hub. In this episode, we explore one of the most powerful objects in our solar system, the Sun. The Sun is the star at the center of our solar system. It is enormous and incredibly powerful. This giant star produces the light and heat that reach Earth every day. It is made of extremely hot gas. So hot, the gas becomes plasma. Most importantly, the sun's gravity holds the solar system together. It keeps the planets moving in their orbits, including our home, Earth. How the sun was formed. The sun was not always there. It formed about 4.6 billion years ago. At that time, the space in this region was filled with a massive cloud, a cloud of gas and dust. Scientists call this cloud the solar nebula. Over time, gravity began pulling the cloud inward. Slowly, the cloud started collapsing, and as it collapsed, it began to spin faster. More and more material gathered in the center. The pressure increased. The temperature rose dramatically. Eventually, the center became so hot and dense that a new star was born. That star became our sun. The size and the structure of the sun. The sun is truly enormous. Its diameter is about 1.39 million kilometers. To understand this size, imagine this. More than 1 million Earths could fit inside the sun. Almost all the mass of the solar system is concentrated in this one star, about 99.8%. Inside the sun are several layers. Each layer plays an important role in moving energy from the center outward. From the deep core all the way to the glowing outer atmosphere. So, what exactly is the sun made of? Mostly two elements, hydrogen and helium. About 74% hydrogen and about 24% helium. The remaining small portion includes other elements, such as oxygen, carbon, and iron. But inside the sun, these gases behave differently because the temperature is extremely high, millions of degrees. At these temperatures, matter becomes plasma, a very energetic state of matter. This plasma constantly moves and flows throughout the sun. How the sun produces energy. At the very center of the sun lies its engine, the core. Here, temperatures reach about 15 million degrees Celsius. Under such intense heat and pressure, something extraordinary happens. Hydrogen atoms collide, and they fuse together. This process is called nuclear fusion. During fusion, hydrogen atoms combine to form helium. And when this happens, a tremendous amount of energy is released. This energy slowly travels outward, eventually leaving the sun as light and heat. And after a long journey through space, that energy reaches Earth. The sun's surface, sunspots, and solar flares. The visible surface of the sun is called the photosphere. This is the layer we see from the Earth. Sometimes dark patches appear on this surface. These are called sunspots. Sunspots are slightly cooler regions. They form because of intense magnetic activity. But the sun can also release much more dramatic events. Sometimes the sun erupts with powerful bursts of energy. These explosions are known as solar flares. Solar flares can send huge amounts of radiation into space, and occasionally they even affect satellites and communication systems on Earth. Solar energy and how it reaches Earth. The sun constantly releases energy in the form of light and heat. This energy travels through space as radiation. Even though the sun is about 150 million kilometers away, sunlight reaches Earth surprisingly fast. It takes only about 8 minutes. When this energy arrives, it powers almost everything on our planet. It warms the atmosphere, drives weather systems, and allows plants to grow. In other words, solar energy makes life on Earth possible. Why the sun controls the motion of planets? The sun is not only a source of energy, it is also the gravitational center of the solar system. Because the sun contains almost all the mass, its gravitational pull is extremely strong. This gravity keeps the planets from drifting away. Instead, each planet moves along a curved path and orbit around the sun. Without this powerful gravity, the solar system would not exist as we know it. Now imagine something dramatic. What if the sun suddenly disappeared? First, Earth would become completely dark. Within a short time, temperatures would begin to drop rapidly. Our planet would become extremely cold. At the same time, the planets would stop orbiting. Instead, they would move in straight paths through space. And without sunlight, life on Earth would not survive. Fortunately, the sun still has billions of years of life ahead, so for a very long time, it will continue to power our solar system and sustain life on Earth.